Hello everyone. Sit back and prepare to enjoy this talk from DevFest Montreal.
Great. So like I have said, I work at BRP. So what we basically do at BRP, so at BRP we are, sorry. Okay, at BRP we build the recreational vehicles. So our most popular brand is the Can-Am. So the last product was the Can-Am motorcycle vehicles, and we also build the most popular one, the Ski-Doo, and the Sea-Doo, the Can-Am Mavericks, and other bunch of products. And some of our latest products came with connectivity, so which means that at some point you can be able to connect your vehicle to the phone and being able to interact with it, right? So in order to have access to some capability that came with the vehicle. And also we have an app, it's a BRP Go. It's a fully offline navigation app that is integrated to the vehicle that the rider can use to navigate across different features that's available. So one key challenge that we have right now is the fact that when we are developing a new feature for the application that is supposed to run on the vehicle, so we used to use some, I would say, early device that don't necessarily have the right performance to work with, right? That's why the most of the time we are dealing with some performance issue. And in this talk, I will try to share with you guys, so what is the techniques that you can use when it comes to investigate and to try to improve the performance of your application. So when we talk about performance, the most of the time we think about monitoring, right? So the monitoring is trying to understand what is happening remotely on the user side. So what's happening when the user tries to click on this button, there is a crash or something like that. So you're trying to monitor on the user side. Also, when we think about performance, we try to think about benchmarking. So benchmarking is when you run some small script in loop, right? In order to be able to measure the performance, and you made some change in order to be able to make some improvement. And the last thing when we talk about performance is profiling. So profiling is basically analyzing the performance of a running program, right? To understand how it uses resources, and it can be a network, a GPU, CPU, I/O, and etc. And today we will be most focused on the last one, profiling. So we'll try to see different techniques that can be used when it comes to do profiling. So profiling, it's really important to remember that when it comes to do profiling, it's really important to do that in some conditions that are really close to the production environment. So don't do that like on a debugging version of your application, because we all know that if you are using a debugging version, there are a lot of stuff that are added just to make your application to compile much more faster. The debug version doesn't have all the optimization that we used to have on a release version of your application. That's why it's really important to make sure that you are using a version of your application that is really, really close to the one that will be in production. Secondly, it's really important to don't just trying to profile for no reason. So you have to have a reason why you are doing that, which problem you are trying to solve, etc. And also, when you are doing profiling, try to avoid using mock data, because right now you are trying to understand exactly the behavior that the user is facing right now. And the user is not using your mock data. The user is dealing with the real data. That's why when we are doing profiling, it's really important to use, I would say, production data if you can. And also, no emulator at all, because we all know that the emulator is not a real device. It's a really great alternative when you are testing, but for profiling, it's really, really important to not use the emulator at all. So example, when you are using the emulator, right, you may having some disk problem, right? But when you run the same application on the real device, it can be a CPU problem. So that's why it's really important to test on the real device to be able to find the real problem. And also it's really important to generate a profilable build, right? Why? Well, because when you create a profilable build, this will make the profiling tool to collect as much information in order to be able to investigate, to understand exactly what is going on. Okay, in order to be able to create a profilable variant, so you just need to add this couple of lines of code into your Gradle configuration files. So you have just to make sure that this profilable variants extends the release one, just to make sure that you are not using the debug version. And after that, if your application is using several modules, you can do the same thing with the module that require to be profilable, because sometimes Android Studio can complain about, hey, this module is not, I can't find a profilable variant for it. And lastly, you need to add this tag into your manifest. So profilable shell true, right, to make your application being able to provide some data to the profiling tool. Great, so now let's try to see the profiling good practice. So first of all, when you are doing profiling, it's really important to do the investigation outside in. So that means you are starting from the outside of your application. Don't jump in the code right away, right? So trying to understand, start from what you are seeing, what you are noticing. So for example, you are seeing that navigation from screen 1 to screen 2 is kind of slow. The application launch time is quite high. So start from the global side of things, I would say. Start from what you can notice. So for example, start from the UI perspective. So it can be, you notice that the UI is freezing at some points. The scrolling is lagging. And try to look at the entire system as so all your application is interacting with the Android system. And the thing that you don't need to do, right, it's basically a waste of time. So don't just jump to the code right away like I've said previously, because it can make you spend quite a lot of time doing that. And don't just reverse the last change that you have made, right? Oh, the last pull, it's probably the last pull request that we have merged that create this problem. It can be true, but it's not necessarily the case. And try to avoid some random fix. So for example, you find an issue, let's say the application startup is kind of slow, and you're trying to do some random fix. That also can make you spend quite a lot of time. So one thing that can help you to do a very great profiling is try to start by writing some signal and some facts. So for example, is the application startup is slow? Just try to write down. So for example, and write some hypotheses and try to prove or disprove them. So for example, are we doing too much stuff in the onCreate method? So, or are we doing too much stuff on the main thread or something like that? Try to write those down, right? And after that, you try to create what I can call your investigation note. So for example, you can write down the navigation from, let's say, screen 1 to screen 2 is kind of slow. The animation is not smooth. So, right, so the animation or the transition is not smooth, is not is kind of slow, right? So, is the creation of the activities slow? So try to write all the information that you have noticed while doing your investigation. Are we breaking the main thread? That's a really good question, because when we are doing the Android development, so the most of the time we used to block that thread a lot. So try to ask yourself those questions, right? And then you will try try to understand if they are really the problem is related to that particular part of your application. So now let's try to see some profiling techniques. The most popular one is tracing. So what is tracing exactly? So tracing is the process of recording detailed information about how your application ran over a certain period of time. So basically, tracing is trying to understand what's happening when, for example, you click a button that's help you to navigate from screen 1 to screen 2. What is happening behind the scene? So what methods are being called, what thread is being involved, and all bunch of stuff. And in order to record a trace that contains all the information about the running status of your application, there are different approaches that you can use. So the first one, you can use it from the Android profiler. So the Android profiler is, I would say, a tool that is already integrated into Android Studio, right? It's something that looks like this. So as soon as you click on the profiling icon, so you will see the list of applications that are profilable, right? And you have a bunch of options that you can use. So you can run you can capture some system activities, memory activity, CPU activity, etc. Another strategy, you can use ADB, the Android Debug Bridge. So as an Android developer, we use a lot the ADB. It's the tool that helps us to communicate with the device. So you can also do that. So in order to do that, you just need to use these ADB commands. So ADB shell profile stats, right? And you specify the package of your application, right? And the path on the device in which the trace file will be created. After that, you can try to manipulate your application a little bit just to try to collect some information. And if you are sure that you have collected everything you needed, you can just call profile stop and you specify the package of your application, and the trace file will be saved on the path that you specified. And after that, you can pull that trace file to your machine, and you will be able to analyze it with a bunch of tools that as we are going to see in a couple of moments. Another option to record a trace, you can do it directly using your phone, right? So for example, you just need to go to enable the developer option. So if you're an Android developer, probably it's already enabled. So if you scroll a little bit, you will find this menu, system tracing, right? And under the system tracing, you will see this toggle here. You can use it to enable the system tracing icon in the quick menu. Once it's done, you will be able to see this button on the quick menu. And as soon as you click on that menu, it will automatically start doing the tracing on the application that is running. And the last tool that you can use is Perfetto, right? Is the tool that we are going to use for this presentation. So what is Perfetto exactly? So Perfetto is an open source suite of SDK, daemon, and tool which use tracing to help developers to understand the behavior of a complex system. So it's not only related to Android apps, so you can use it on Linux, Mac, embedded system, not only for Android. So in short term, I would say Perfetto is a tool that allows you to, first of all, record the trace, right? Visualize the trace, right? And try to see what is going on over the time. So basically, Perfetto have 3 parts, right? The first part is the recording trace, right? So that is the starting point. You try to record a trace. You specify the stuff that you want to record. After you have the trace, you can analyze it, try to see what's happening, what's going on when I click this button, what's happening on when the application starts. And you can also visualize all the information that has been collected in the trace file. So what you can do with Perfetto? Well, there are a bunch of stuff that you can do. So you can track the frame rendering performance. So for example, you're trying to understand why your application is lagging, so why you have some junk frame or the performance is low, the way that you can analyze how well your application is rendering the UI. You can also try to monitor the CPU usage. So for example, let's say when you are doing some piece of work, you notice that the CPU consumption just become too much high. You can also try to identify if the main thread has been blocked or not, try to understand what is happening right now on the main thread. You can also try to have some metric regarding the app startup. So right now, the app startup is, I would say, one of the most common frustration when you are using an Android application. So you launch it and you have to wait a couple of seconds before starting using that application. So with Perfetto, you can have a clear idea about what is happening exactly when I start my application. You can also try to understand the memory allocation. So for example, am I doing stuff that is taking too much memory? So you can have a good understanding about at which point the heap is, I would say, full. And also you can track some I/O operations. So for example, this one can be really interesting to try to see if you are not using, you are not doing I/O operation on the main thread. That can probably block the main thread. And also you can try to monitor the power and battery usage. And there are a bunch of stuff that you can do. So for example, if your application is using a local database, you can track the performance of the queries, the SQLite queries, so how many times each query took to execute. So there are a bunch of stuff that you can use with Perfetto. But for this talk, we will try just to see some simple use case, right? So I will try to open my Android Studio here. Great, so let me try to increase the font a little bit. Let's say 20. Great, so I have a very small application here, so I will try to launch it, and we're going to see, we'll try to do some, we're going to use the Perfetto to see the performance regarding this application. So I will try to mirror my device. Okay, here we go. So as you can see, so I have already do all the setup that I have explained, create a profilable build to make sure that we are going to collect as much information for profiling. And okay, so as you can see, I have this small application here. So there is just this text field, and I can write something, right? And when I click this button, I just navigate to another screen, right? So let's say I want to add some new feature on this beautiful application, right? Let's say I want to display some images, right? I will just uncomment these two lines of code, right? So I have two images that I have put in my resource files. So yeah, I have those beautiful images, right? So I will try to run the apps again and see what's gonna happen. So as you can see, the installation is taking too much time because this is a release version of the application, not the debug one, right? Because all the optimization doing by Android Studio has been disabled, so that's why it's taking too much time. So I have the same thing. So as you were noticing, so navigating from screen 1, from screen 2, using the first application without the image was super smooth. So we were just navigating straight to the. So I'll just try to remove those two images, just to make you guys notice the difference. For example, I don't have those images. Try to run the application, and you are going to see that the navigation is really, really fast because I'm not doing anything. I'm just navigate to I would say, an empty screen that's only display a text that came from the other screen. So for example, if here I write some random stuff and I click go to screen 2, as you can see, the navigation is kind of really smooth. All right, I can do that again so we can notice the difference. Great. So now I will try to add those two images, right? And let's try to build the application and see what will be the impact. So we all know that when you are building an application, Android application used to have a lot of images, a lot of icons, and as you're going to see, sometimes what you include in your application can have some performance impact. So as you can see here, I'm not doing something fancy, right? I'm just loading an image from the resources. And as you can see, as soon as I try to doing the same thing, it's like taking a couple of seconds before navigating to the next screen. So it's kind of not really great to notice, right? But we are going to analyze and to see what's the difference, right? So first of all, let me try to comment back this code again, right? And execute the app. And then we are going to record the trace before adding those two images. And we are going to see the before and the after. Okay, the application is launched. And in order to do that, right, to use Perfetto, you just need to go to this link, ui.perfetto.dev. I will try to increase the font a little bit. As you can see, it's a web-based interface, right? You will see there is a bunch of options that you can have here, right? You can decide to use a stable or a canary version. You have option to trace some sample application or Google Chrome example. So in order to record a new trace, just click this new, record new trace, right? And you will have a bunch of options. So like I have said previously, so Perfetto is not only dedicated for Android, so you can use it on on Chrome, Chrome OS, Linux, and different other kind of stuff, right? But for this demo, we are going to use it on Android, obviously. So let's do some configuration. So the first one is you're going to decide on which device you're going to record a trace. Is my device here, the Pixel 9 Pro. And let's do some setup. So for example, here, I want the recording mode to use this amount of memory, and I want the tracing to take, let's say, 30 seconds. So it depends on what you want how long you want to record a trace. And also, I want to get some information regarding the CPU usage, right? I can come here, right, and try to, you can try to enable the thing that you want to record. So for example, for me, I want to the scheduling details. So I want to see how the system is scheduling stuff on different CPUs that I have. Also, I want to have the CPU frequency, just to see the peaks and the variation between the CPU. And you can also have some system call. So this can help you to see the context switching. So for example, when your application is making a request to a kernel-based feature, so we are not going to use that You can do the same thing from the GPU, so you can try to, if for example you are building a video game and you want to have a good understanding of how your application is using your GPU, you can do the same thing from the power, the memory, right? So you can try to understand how your application is using the memory. And there is also a bunch of stuff regarding to Android. So for example, one of the thing is the A trace. The A trace is the traces that has been by default included into the Android operating system. So a lot of Android components already came with some trace functionality that can help profiling tool to collect a bunch of information. And here I will select all of them. So ADB, the audio, the binder, cameras, a bunch of stuff that we are going to see. And I can decide to get also the log if I want, right? And this one is really important. So for example, if I want to see how my application is rendering the UI, so in order to be able to understand the performance of the UI. And you can also track the network tracing in order to have a good understanding of, about a bunch of information about the network traffic. So this application is not using any network stuff, so we are not gonna using it. There are a bunch of stuff that you can use, right? You can do some stack sampling and a bunch of other stuff, but we'll just limit ourselves to this, because if you try to enable everything, you will have a bunch of information, and sometimes navigating over all this information can be quite cumbersome. So what I'm going to do, I will close the application, right? And after closing the application, I will go back to this first option. I'll just make sure that my device is connected. So one thing that is really important here, in order to be able to do the tracing, you have to make sure that, because this tool will try to communicate with your device, and Android Studio is also doing the same. So if you try to connect, it will do this error message. So the thing here is to just go and close Android Studio, right? And after that, you will be able to connect properly. Here we go, allow. And as you can see, the device has been able to connect to Perfetto. Once it's done, what I'm going to do is just play this record button, right? And you will try just to manipulate your application a little bit, try to enter a text, try to navigate back. And once it's done, so you can wait until the amount of time that you specify a reach out. So, or if you want, you can just click this stop button, and it will try to record everything and create this ptrace file. Right now there is an issue with Perfetto. I don't know why, but most of the time when you record a trace, it's opening it automatically, but it's not doing that right now. So what I'm going to do, I'm just going to download this ptrace file. I'm going to save it, let's say here. So let me just rename it in order to be able to find it properly. So for example, Android.ptrace, and I'm going just to open a new UI, and then I will just open that file. And here we go. So as you can see, the ptrace files contain a lot of information regarding our application. As you can see, the first thing that you are going to see is how many CPUs you have on your device, and all the stuff that is happening on every single CPU. So you can see the scheduling information. You can see the frequency information. So for example, you can see every single CPU, the workload on that particular CPU. You can see also the same thing from the GPU. So for example, I have two GPU cores, so GPU 1 and GPU 2. So you can see also the frequencies. And you can see something here is called Android App Startup. This is not, so we'll try to ignore it for now. But the thing that you are going to see here, all are the process running on the device. So Perfetto didn't just record the stuff regarding the application that I've just started. So it records everything on the application. So the idea here is to try to understand how my application is interacting with the entire system. And you can see there are a bunch of stuff, power section, device state, CPU, and you will see a different process. So for example, here the Android process, the ptrace, a lot of stuff here. And one thing that we are looking for is something that is related to our application, because we are not trying to understand the performance of the existing app. We are going to understand the performance of our application. So we are going to try to find it. So just try to find the package name of your application. So here it is. So you can see this application. This is the process of my application, right? And if you click on it, you will see the bunch of stuff that appear. So for example, there is this two section, expected timeline and actual timeline. I'm going to explain it a little bit later. But after that, you will see the threads that are running on your application, right? And as you can see right now, it's kind of messy. You don't see anything, right? And you can use some keyboard shortcuts here. So you can use the WE and S to zoom in, zoom out, and you can use A and D to pan left and right. So for example, here I have my application, right? You can see this first thread is called the main thread. So Perfetto has been able to identify what is the main thread, and as we are going to see what is happening currently on the main thread. The first line here is referred to the states of the threads, and the second line is what's going on that particular thread. I will try to zoom in a little bit to try to see. So for example, from here, try to zoom again. As you can see, things start to be interesting. As you can see, your application starts somewhere here. You can see there are different states, runnable. So if you see the thread state runnable, mean the thread is ready to run, but is waiting to be scheduled, right? And running, that's obvious, the thread is running. And this bar here can help you to understand, is this your thread is being blocked, or it has been waiting too long, or something like that. And let's go back to one thing that we have seen before here is this app startup, Android app startup. This is really important because it's a metric that has been collected by Perfetto that help you to understand how long your application take to start, right? If I try to zoom out a little bit, right, I can click on this slice. This bar here is called a slice, right? If I click on it, you can see a bunch of information, when the device starts and the duration. So as you can see, my application took only about 100 milliseconds to run. So you can use this information to identify if your application is taking too much time to run. So once this slice is selected, I just need to click the M keyboard, right, on the keyboard, and you will see this portion will be selected. This is really interesting because you can see while the application is starting, right, the other bunch of stuff that's happening in the same time. So for example here, during the startup, we can go back to the main thread and try to understand what's happening exactly. So for example here you can see the bind app, you can see here the activity starts, all the choreographer that's happening. Here we try to measure the UI, right? And you can see a bunch of stuff here during that particular main thread. And let's try to scroll a little bit. You can see some render threads that is happening here. And let's go back to this two line here. This is expected time and actual time. So what does it mean exactly? These two lines mean that a frame is supposed to take a bunch of time in order to be able to be rendered. So for example here you can see this frame took 60 milliseconds to be rendered, which is, this is the expected time, but the frame took only 1 millisecond. That is really great. And if you see a frame that is taking too much time, more than 60 milliseconds, that means that there is a problem. Maybe you are doing something on the main thread that is blocking the main thread. So this is great, right? And this trace is not really interesting because the application is running great, so we don't have anything really fancy. So we're going to go back into Android Studio. Let me open it again. And now we're going to add our images, right? And we'll try to see what will happen, right? I will try to install the application, and after that, we'll try to record a trace regarding this application. So let's try to go back on this. As you can see here, the app startup was taking about 100 milliseconds, and after this line here, that means the application fully starts up, right? And from here to this portion here, the application is running, is probably doing some animation, rendering the UI. So everything is kind of great, right? And if you want to know, for example, how much a portion of code took, you just need to draw, let's say, a rectangle, and it will select, and you will be able to see that this particular section took only 5 milliseconds to execute. Right? It's relatively slow, and it's really great. So the application is start, right? I'm going to close it, right? Because I want to record a trace when the app when I start recording this. I will try to record a new trace. I will keep the same configuration. Start. Make sure the device is connected. If it's not connected, try to close Android Studio to avoid having the conflict. Okay, let me go back. Try to select it again. Android Studio is connect a new device, select the device. Yes, let me try to unplug and plug it again. Okay. Allow. Okay, here we go. Now I can run the app again. Try to do the same manipulation. There is something that I forgot. I forgot to uncomment those images because I don't see it in the application right now. We'll stop it. Open Android Studio and try to add my images. Oh, yes, I have them. So let me try to install a fresh version of the application on the device. Here we go. So one thing that I want to demonstrate here is the fact that I have put some really big image, right? And those images take too much time to load. So if you have a very powerful device, it can be kind of hard to notice that, right? Let me just check if the image are being displayed. So here we go. So now I will close the app once again. Close Android Studio. Go back to Perfetto. Allow. The device is connected. Let's start recording a new trace. Do the same manipulation. And go to the second screen. Go back and stop the trace. We'll be having the same issue. Hopefully this time it will open it directly. No? Okay, let's try to save it again. So I will try to call it, let's say, I can find another name. So for example, Android 2, save it. I don't know why there is this issue. Open a new interface and try to open that file. Still the same because the operation right? And we are going to find the startup. This is the startup, right? I can pin it if I want, right? Try to zoom in. Okay. Try to select this startup section. See if there is a bunch of stuff. So right now we have about, I think it's practically the same like the previous one. But let's try to see a little bit what is happening on the application process right now. So as you can see, there are a lot of bunch of frame that has been rendering here at 16 milliseconds, which is great, right? And let's try to continue. But as soon as you reach this point, you will realize that there is this very, very long frame. So for example, that took about 58 milliseconds, right? You may wondering why we are having too much time. So for example here, you can notice here it's taking too much time to render this frame, about 302. And let's try to understand why. Well, as you can see, there is this section here, image decoder, that took about 184 milliseconds to display. That is really long, right? And we don't want it. And there is another section here, image decoder, that took around 100 milliseconds. That is really long, right? So let's try now to find a way to optimize it. As you can see, Perfetto helps us to understand why the application, why the navigation is kind of slow. We have understood that the image decoder is taking too much time for both images. The first image is taking like less time. And if you open Android Studio, we are going to notice it a little bit. As you are going to understand that here, the first image, let me open it. The first image is a really, really big image, as you can see, based on the resolution and the size. It's a really big file. The same thing here, it's a 2 megabytes of image. So one solution of optimization can be to try to convert these two images into a more optimized version. So right now, the image decoder for the first image is taking like 100 milliseconds, and for the second one is take 180 something, right? First of all, since we have noticed what is the problem, let's try to optimize a little bit. I will try to select those two images and try to convert it into a WebP, right? WebP is a format that helps us to reduce, to try to compress the image by keeping the same quality. So I'll try to do the same, okay? And let's try to see what we are going to get, okay? So I can decide the quality that I want. As you can see, here we are going to see the preview, the original image, the WebP version, and by using this slide, you can see what you are going to gain. So for example, here, the original is 3.9 meg, and the converted one will be like 1.5 megabytes. So here we'll try to use the default one, right? And the image will be, the original will be 3.9 meg, and the converted image will be like 300 KB. I will accept all, and let's try to see if this will solve our problem a little bit. So let's try to execute the application and see what are we gonna have. Are we going to gain some performance, or it will be the same thing? Okay, let's try to run the app. Let me make sure I mirror the application. So the fact that the way that we are launching, we are loading those two images after on the screen too makes the navigation quite not really smooth. The app is just launching. Here we go. Let me try to write something. Let's try to navigate. It's still slow, I think. So I have the impression that I haven't made that much improvement. So let's try to see by recording, by recording the trace of this particular change that I have made. So maybe I hope they will fix this problem that's make me to close Android Studio every single time. I will try to record another trace. Make sure the device is connected. Great. Start the recording. Open the app. Try to manipulate it a little bit. Navigate. Go back. And that's it. After that, we are going to save this file since Perfetto is refusing to open it automatically. And let's call it 3. And let's try to open it. Let me just close it and open a new one. Okay, these 3. Okay, so let's try to see if we are going to spot any difference, right? The problem that we were having recently was the fact that the application was taking too much time to load the image. So one thing that if you already know what you are looking for, you can directly type it on this search bar. So for example, image decoder. And you will be able to, there are a bunch of image recorders, so I will make sure that I've selected the process that I'm interested in. So this one. And here, I will try to find for image decoder, no that one, no that one, no that one. Okay, here we go. So, as you can see, the small modification that I've made has been able to make us to gain some, I would say, optimization. Lastly, we were decoding the image in 100 milliseconds, but right now we are doing it in like 60 milliseconds. And for the second image, it's taking only about, so I think it doesn't change that much, I have the impression. So is there any way that we can optimize it? Well, one solution that we can use, since those images are kind of big and beautiful, obviously, so let's try to see if we can try to do this work not in the main thread, but trying to do it asynchronously. So what we are going to do, let's go back to Android Studio. So instead of using these image components coming from Android, I can use this async image, right? So basically what this gonna do, it will do the same thing, right? But instead of waiting on the main thread until the image gets loaded, because displaying an image is kind of an I/O operation, because you will go and read the file and try to display it. So we are going to use this async image. So this is what's gonna happen. So it will not block my UI. That means navigating from screen 1 to screen 2 will still be smooth, right? But the image, the user can be able to notice that the image took some time to be displayed. So let's try to see if we are going to have the improvement we are looking for. Let's try to run this for the last time. Try to mirror the application. Here we go. So right now, as you can see, it's still kind of laggy, I would say. It took a couple of, I would say, milliseconds to transition to the new screen. So right now, I think we should have the same behavior like we were without having the image. So the app is launching. And now let's try to see what kind of happens. So now the animation should be smooth. Here we go, as you can see. It's kind of really fast. And the image, the UI doesn't wait until the image is getting loaded before transitioning to the next screen. Let's try it again. As you can see, it's kind of smooth. Those kind of optimization, you can notice them with numbers, I can say, using tools such as Perfetto. So now let's try to record for the very last time in order to see what's happening exactly. I will open Perfetto again. So as you can see right now, this image decoder is taking 67, and this one 130. Let's try to record a new trace. Make sure the app is connected. Great. And record. Let me open the app, do some manipulation, navigate back, and stop the recording. Not opening it automatically, so I will download it again. So normally you don't have to do it like this way, because as soon as Perfetto finish recording a trace, it's open it automatically. Let me call it final, and then I will open it in a new tab. Open trace is what was the name again? Final. Great. Let me try to find again the app startup. I don't want to see the stuff relating to the app startup. Where is my app process? Okay, here it is. And let's try to see if we have been able to gain some improvement. I will also check for the same thing, image decoder. Not. Okay. So as you can see, now things are much more, no, this is not what we are looking for. Nope, nope, nope. It's not this one. Let me try to open the right one. Where is my app process? So I know sometimes it can be tricky to navigate inside Perfetto. Okay. One thing that you have noticed is the fact that you don't have that red, that big red bar that we were seeing here when we were rendering the frame of our application. As you can see, every single frame in our application has been rendered in 16 milliseconds. That is great. That means that we are not blocking the main thread anymore. And I'm going to find where that image was launched. Image decoder. Nope, it's not this one, not this one, not this one, not this one. Okay, let me try to find it manually. Okay, I think it should be somewhere here. Okay, it's not here, drawing. Okay, let me try to see. Is this there? let's find just image, surface finger, image deck. Nope. Nope, nope, nope. Okay, let's try to see here. Great. As you can see, one thing that is really interesting is the fact that before, when I was launching, I was displaying the image, that section here was appearing not inside this thread pool here, but it was made inside my application main threads. As you can see, by just changing image from async image, that means that the loading, I would say the loading of the image has been moved from the main thread to another thread that make our thread to be much more lighter, that help us to have this smooth transition. There is a bunch more that you can do with Perfetto. So we don't have too much time to try to expose every single stuff that you can do. Like I was saying, you can be able to track the performance of your local database performance to see what's happening exactly when you try to save a bunch of data into your application. And let me try to go back to my presentation. So that was basically it. So one last thing that you can do with Perfetto is the fact that sometimes you want to, so as you can see right now, I was kind of struggling trying to find the exact place of what I'm looking for. So there is this feature in Android that helps you to mark some sections. So for example, you can put some kind of label, right, in your code. So for example, I want to try to understand what is happening between this line of code and this line of code, and I'm doing some computation in between, right? You can use this trace begin section, and you use a label, right? And you end that section using trace.end section. And then after that, you will be able, when you record a trace, you will be able to search for this particular label into Perfetto, and you will be able to see the exact session, and that will give you much more flexibility when it comes to track the app performance of your application. So that was basically it, and thank you. I don't know if there is any questions.